My name is Marianne Bellotti, and I'm a software engineer. Right now, I'm working with the Department of Commerce on setting up technical SWAT teams. But today, I want to talk to you about a lot of work that I did for the past year for an organization called United States Digital Service. Quick show of hands, who has ever heard of USDS? OK, how many people have heard of you before you talked to me this week? OK, cool. All right. So very briefly, for those of you who never heard of us, US Digital Service basically focuses on helping the government provide better digital services to citizens through technology. It's sometimes difficult for private sector people to really understand why government technology is so difficult. Like, the government invented the internet, so why does it struggle so much in building websites that operate on top of it? Especially since they have access to talent and almost infinite money. But what we need to understand about good user experience and good digital services is that the way the private sector defines it, often by pushing boundaries in privacy and security and free markets that are not appropriate for the government to mimic. So for example, as a consumer, I love it that I can go to Amazon and literally order anything I can possibly think of. But is it great for the economy that all of that power is focused on one company? Probably not. I love that I can go to Facebook and look up people I went to high school with. But is it great that Facebook has all that data about me? Probably not. So a lot of times when I come into a technical project in the government, the big thing that is creating all these blockers is actually like legitimate concerns about what is appropriate for the government to be doing with data, what is appropriate for them to be collecting data, and how they should be configuring their systems for optimum security. So I think it's important to understand that the men and women of USDS are not geniuses. We're just people that are empowered to roam across silos and across organizations to diagnose technical problems and ultimately find a resolution to them. TIC, Trusted Internet Connection, is a really good example of this effect. So this is David. David works for USDS. Before he came and worked for us, he was the head of engineering at OkCupid. And he comes up to me one day and he says, I'm working on this project, and the architecture that they're telling me I have to use, it seems pretty insane. And they keep telling me that I have to use it because of this thing called Trusted Internet Connection. And basically, it looks like this. Our website is at AWS. And when people come from the public internet to this website, they're not allowed to go directly to AWS. They must go to a government data center, and then the government data center reroutes the connection up to AWS. And he goes, well, that would be one thing, except we also, backing that web app, have a Dynamo database. And whenever the web app wants to talk to the Dynamo database, it must route its connection through the government database and then back to the Dynamo DB. And he's like, this is particularly unusual because both the EC2 instance in question and the DB in question are in the same data center in Amazon Cloud. So why do we have to route connections out of the data center to go back into the data center? And so he says to me, has anybody in USDS ever worked on TIC before? Is this a problem we can solve? And I was like, well, you already know Brody, who we kind of poached from Stripe's security team. And there's actually another person over at the VA named Aaron. And Aaron's kind of an interesting case because he's actually was a lawyer with the EPA. And so a lot of times when we're trying to diagnose these technical issues, we have people who come in and be like, stop. What you're doing is illegal. You can't do it. And so for us, the most valuable people on our team are this small group of lawyers that kind of like swashbuckle in and go, no, it's not illegal, and then fence with the bureaucracy to like clear it out of the way. And so when we originally hired Aaron, we thought that's what he would do. And then he showed up, and it turned out he also knew all this stuff about computing networks, despite having no computer science on his resume whatsoever. And we were like, well, OK, we're going to go with this. You can go do that as well. So I said, so we got some engineers that really work hard on these kind of issues and have some experience and opinions on them. So let's get them together. And by the way, the people in the Office of the Federal CIO that work on technical policy are aware that this policy is broken and have been trying to fix it desperately for like 3 years. So let's go work with them too and see if we can find a solution to it. So that brings us to the question, what exactly is a trusted internet connection? So trusted internet connection is a policy that was written in 2007. Essentially, it is an access point. What trusted internet connection policy says is that whenever something on your internal network wants to talk to something external, it has to go through this very specific access point called a TIC. And that access point will have intrusion detection connected to it, and each agency can only have 2. It says sort of, because the people who wrote that policy were the first to agree that it was something of an arbitrary number, and you have agencies like NOAA and the FBI that actually have a legitimate reason to have more than 2. So it's all about restricting access to government networks. Yeah, and so the intrusion detection systems that they're using are also signature-based, not anomaly-based. Some of those signatures are classified, but they look at packets and they match known threats, known patterns of malicious activity. So back in 2007, this was not a terrible thing to do because the internet looked completely different in 2007. So for reference, the iPhone had just come out. First generation, there was no app store. So we're in the beginning of the smartphone revolution, but we're not really very robust in the smartphone revolution. EC2 and S3 had just come out. It would be a year before Google and Microsoft started to really move into the commercial cloud market. And people were still somewhat skeptical about software as a service. It was still like, yeah, it's a nice thing. It might lower some costs, but don't put anything critical on it. The problem is that it's 2017. It's a decade later. And how do you define perimeter security when your perimeter is basically dissolving in front of your eyes? You know, how do you define perimeter security when your email, which most organizations would consider an internal capacity, is run through Google Apps or Microsoft 65? When you're using applications like Concur and Salesforce to do critical business functions, when your employees expect to be able to work remotely, particularly your technical ones, when you're moving all of your stuff out of a data center and onto some sort of infrastructure as a service like Amazon or Microsoft, et cetera. So the way people deal with TIC in 2017 is by finessing the definition of internal and external to a somewhat insane degree. In theory, external applications are not supposed to have sensitive government data on them, but what sensitive government data actually means is up for debate. It's basically the agency has a lot of flexibility in defining that. There are some guide rails. For those of you who are not familiar with the landscape of government technology, there are 2 really important things to understand, FISMA and FedRAMP. They're kind of difficult to grok because they sort of overlap a lot, but the way I think about it is that FISMA is how you define the security level of a system that you are building based on the type of data that it's running. And FedRAMP is how we certify products and services that other people are trying to sell you as to whether they are equivalent to that FISMA level. So if you build a FISMA moderate system, then the architecture that you buy from Amazon needs to be FISMA moderate certified. So, oops, forgot one thing. In addition to that, some agencies actually have laws that Congress has passed specifying how they handle their data and what they can and cannot do. The 2 big ones to know are Title 13, which specifies how the census can use the data it collects on you, and Title 26, which specifies how the IRS can share your data. The IRS especially takes this very, very, very seriously. So let's go back to this example. What is actually happening in this architecture? This architecture actually looks like this, where these 2 items are defined as internal systems, and these 2 items are defined as external systems. And so as a result, whenever an internal and external system want to talk, they have to talk through the TIC. This is another example. We got a mobile application, we want it to talk to the cloud. If you've managed to define both of these things as external or both of these things as internal, they can just talk like this. But there are many situations in which you might say, like, no, our mobile applications are in fact internal and our cloud environment is external, in which case they have to do this. Or realistically speaking, that probably looks more like this. So what further complicates the situation with TIC is that most agencies, when they want to go onto the cloud, they go on what's called Amazon's GovCloud. This is a specific data center that Amazon has set up to handle the US government's specific security needs. Really, the major difference between GovCloud and normal AWS is that GovCloud data centers are staffed 100% by American citizens. And there are some differences in the products that are available. Elastic Load Balancer doesn't have the full range of features that it does on AWS. The marketplace doesn't have the full range of potential products and services to use. The agencies are also required to use DHS's special classified intrusion detection software. So there's always, whenever we talk about reforming TIC policy, that always comes up a lot. And we'll talk about that in more detail later. TIC itself sort of creates a false sense of security. Not many people understand exactly what it's doing. They just know that they are instructed to use it, and they are instructed to use it for security purposes. So they tend to assume that TIC in and of itself creates security, when all TIC is an access point. And because it's an access point that everything is running through, it also creates a rather large single point of failure at that. The final complication is that virtually all of our traffic is encrypted now. And when you're doing packet sniffing, you're not really getting that much information out of encrypted traffic. So the usefulness of TIC, whatever usefulness it brought to the table in 2007, is somewhat diminished by the fact that we're all using encrypted connections. So the first thing that we thought about when we thought about how can we change this are various workarounds that we could use. So for example, both Gmail and Outlook allow you to define a custom mail server that outbound and inbound traffic will be forwarded through. So that could give you a TIC-like functionality for mail. We also said, like, hey, you know what? If you took away this 2-TIC limit and let agencies have lots and lots of TICs, we could actually build a government-wide content delivery network. And that could be kind of cool and also kind of useful. The problem with that one is that at least 3 administrations so far have made it a priority to consolidate data centers. So it sort of flies in the face of what the rest of the government is trying to do. They're trying to shut down data centers and move to the cloud. And we would be saying, no, 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 put up more data centers, more TICs, so that you can go to the cloud in a different way. The other things that we looked at are uses of virtual private clouds to further manipulate the definition of internal versus external. And actually, the example that I put up on the board, that's the main reason why DynamoDB was considered external, is because at the time that they made that architectural decision, Dynamo didn't have full support for VPCs. I believe now that's no longer the case, so maybe they'll reconsider and stop running all of their database queries through their data center. The last thing that people sometimes use to work around the TIC is the concept of peering and direct connect, literally running a cable from one machine to another machine so that they're communicating that way. Essentially, the challenge was figuring out, if we want to modernize this, how are we going to modernize it? Like, there's 2 main options. We can throw everything that TIC is out and look at what's done in the private sector now, and just go from there, which is something completely new. Or we can figure out how to virtualize the TIC so that we can move it into the cloud and get the same benefit that is expected from normal conventional TIC, but just not have these crazy architectures where we're going in and out of a data center. Naturally, the first thing we gravitated towards was innovation, particularly because USDS has a lot of engineers from Google, so they were very enthusiastic about this. They're like, well, let's do the Beyond Court thing, zero trust networks. It's like, it's the future. Google invented it. It must be amazing. It is amazing. And the problem with zero trust networks, well, actually, let me take a step back. For those of you who are not familiar with what a zero trust network is, it's basically this idea that every single thing that connects to your network is potentially compromised. And so every single thing that communicates with your network should communicate over mutual TLS. You should use multi-factor authentication on the user. You should have very strict access controls for those users. And you should use good device management. You should basically run your network as if everything on it is not trusted. The problem with this in the government is that it relies really heavily on PKI, which is something that government has struggled with for the last couple years. So in 2004, their Homeland Security Presidential Directive 12 came out, which basically said, hey, everybody, let's do secure IDs. Let's use credentials, make them government-wide, make them super easy to sort of like use from agency to agency. Let's get this done. And 7 years later, the Government Accountability Office, which is a department under Congress, had reported that they had made a lot of progress with this, but it had not yet been fully implemented. And actually at USDS, there's a bit of a running gag about how many badges can you really collect in the government as you go from project to project to project, because none of our badges are actually compatible with one another. I have 3. I would have 4, except the DoD would not give me one unless I agreed to work for them for 6 months. And I was like, you know what? I'm OK with having really cute soldiers escort me everywhere I go. That's fine. So another problem that we have with the Zero Trust Network is that engineering groups in the government are frequently very heavily siloed from one another, not just the traditional wall between development and operations, but also development groups are very heavily separated from one another, and operations groups may be siloed as well. And so what happens in that kind of environment is that one engineering group is trying to build a thing, needs access to something that another engineering group owns, can't manage to negotiate how they get access, so they start looking for cheap workarounds or just quick fixes, which in this kind of environment injects a lot of security vulnerabilities. And so what's important to understand about this is that we generally think about user design as a front-end issue. We generally think about user design as being something that's about making things pretty. But in my opinion, user design is actually even more important when we're talking about network security. Because if people don't understand what makes the network secure, or how to use the network effectively, or how to like work those access controls, then they will ultimately try to violate the access controls, and then you don't have security. So the reason why we put this aside is because we didn't believe that every single agency in the government was capable of implementing it in a way that was safe and secure. So we went back to the concept of the TIC itself, and we thought, like, how do we virtualize this? And then we hit the first big barrier, which is like you can't put the TIC in the cloud because Amazon won't build us a SCIF. So for those of you who are not familiar with the term SCIF, it is essentially a room where you can discuss classified information. I know what you're thinking. You're imagining like huge monitors full of like complex data visualizations and like war room type scenarios. But most SCIFs are the most boring conference room you've ever been in your life. Beige paint on the walls, no windows, no like decor of any kind. It is simply a room where you can discuss classified materials. And the reason why this is a problem is because the TIC reference architecture says that there must be a SCIF 30 minutes away from what's called a TIC management location. And most people assume that what a TIC management location is the data center. So most people interpret that directive in the reference architecture to mean that there must be a SCIF 30 minutes away from your data center. However, the TIC reference architecture actually never defines what a TIC management location is. It never says it's a data center. What it says about it are the following things. The first thing that it says is that it must be in a government exclusive space. It must be staffed 24 hours. It must be 30 minutes from a SCIF. Little side note to that, they never defined 30 minutes by what. So we were kind of like, a 30-minute walk, a 30-minute drive, a 30-minute HTTP request. Like, what are we talking about here? And then the last thing it says is that ops people must have remote access. So everyone assumes it means this, SCIF in a data center, but it could actually very legitimately mean this, just a government building where you already have a SCIF. You use the APIs to manage your TIC at your TIC management location remotely. So then we came across like the big barrier, the thing that has probably killed every attempt to reform TIC so far, and that is you can't put classified signatures in the cloud, and you especially can't put classified signatures in a cloud that you don't own. And so my reaction to this was sort of like, but why do we need to put classified signatures in the cloud? So a little backstory about this. The program that I'm referencing here is called EINSTEIN. And essentially, it is an intrusion detection system that is built by and maintained by DHS. It takes classified signatures and monitors web traffic, well, monitors all sorts of traffic on and off all sorts of government networks across all agencies. And in 2016, Government Accountability Office said sort of like, hey, you know what? They're actually doing a really good job blocking malicious email traffic. They're doing a good job blocking malicious DNS, but they are not doing anything to block web traffic. It doesn't block web traffic at all, in fact. And DHS's own documentation sort of specifies that Einstein is really about situational awareness. DHS had this problem. They were being asked by Congress and by the executive branch to basically monitor cyber warfare and like fight fires around the government. But when an agency was attacked, they generally would not report the incident to DHS. So they needed a way to sort of automate that information so that they didn't have to like go to the agency and require the agency to like follow the rules and report these things effectively. And so one of the problems that Einstein presents is not what it is or even the effectiveness of what it is. It's the idea of what it could do in the future. Everyone gets very, very excited about the Einstein of tomorrow, which will have all of these bells and all of these whistles and fireworks will go off around it. Like, you read the documentation on Einstein and DHS will say, like, in the future we will be able to block web traffic. In the future we will do this. In the future we will do that. But that kind of overlooks the fact that this doesn't actually exist yet, right? We have the Einstein of today. So one of the most important things we did in this process is actually just refocus the conversation and say, like, you know what, we will deal with Einstein of the future in the future. When the seventh seal is broken and Einstein descends and like saves all of our problems, then yes, we will make sure that whatever technology we're running integrates perfectly with it and provides Einstein with whatever Einstein needs to get the job done. But we're living in the today, so let's deal with the Einstein of today and make sure that what we're proposing works with the Einstein of today. So what does that actually mean? A lot of times in these kind of technical conversations, they're a bit like negotiations. And in negotiations, it's really important to sort of understand what is important for you to advance your goal, what your negotiation position is, and what their negotiation position is. So what does Einstein actually need to do the job that it's currently doing? It needs visibility. It needs data. It needs to be able to alert agencies when it detects a problem. And it needs data feeds so that it can do government-wide intelligence. What is USDS concerned about? Is USDS concerned about email security? Not really. I mean, like, we're pretty happy with the government's current email security. Probably could be better, but, you know, like, seems to get the job done. We don't really have many complaints about that. Is USDS concerned about government network security? I mean, if there's a problem, we'll come help out, but it's not really our mandate. It's not really what we're passionate about. It's not what we came to DC to do. The thing we're really concerned about is the public-facing websites. So that's something that I would say a lot, again and again and again, is that what we're interested in and we're going to push based on this interest in getting public-facing government websites to be as scalable and performant and secure as possible. So everything that I say is in that frame of mind, and if there's some reason why what we want to do won't work for your factors, then let's bring that to the table and discuss it. So when we got DHS to agree that all they just needed was visibility into the traffic and a way to alert agencies, the question became, can't we just mirror the packets from the cloud to Einstein? Why do we have to move Einstein to the cloud? Let's leave Einstein where it is and just send a copy of the traffic over to Einstein. And so surprised everybody when DHS came back and they said, yeah, that might actually work if you want to do that, if you want to try that out. That seems like it might work. So then we got to this question of like, okay, how do we do that? So probably the most obvious way to mirror traffic is on a switch. The problem with that is that Amazon is not going to let you access their switch. It's just not going to happen. So it's not particularly cloud friendly. And then depending on the way that you choose it to do so, you might end up dropping packets, which will not make DHS particularly happy. So another way you can think about doing it is on the router. And actually, Amazon does offer the possibility to do gateway routers that do have a certain amount of configuration options to them. But that's sort of Amazon specific. There's no guarantee that other cloud options are going to offer the same services or are going to expose the same configuration settings. So the thing that we sort of settled on was we can do it on the VM level. We can do it with IP tables. But the trade-off there is that that adds a lot of overhead to your image, right? It adds a lot of overhead to your instance. It's not cheap. So when we thought about that, we thought, well, we already have an image that we're running all our traffic through. It's called a load balancer. And load balancers reasonably lightweight. So what if we did this? What if we virtualized the TIC? And we just made it a load balancer that mirrored traffic off to EINSTEIN where DHS can analyze it. Is that a thing that's going to work? And so for our perspective, there is a lot of stuff we have left to sort out. We don't exactly know what the resource load on the VMs is going to be from doing this. And more importantly, we don't exactly know what the load on the network is going to be. Like, mirroring traffic is not particularly cheap. So we had to figure out, like, does that even work in a cloud environment? And the last thing is that we probably want to be able to encrypt this traffic, right? We got to figure out how that's going to happen. But more importantly, we also want to figure out how we can make sure that whatever this ends up looking like, it adds the most value to government agencies. We don't want government people to just be focusing on using this thing because it improves their compliance. We want them to focus on using this thing because it increases their security, increases their performance. We want it to have legitimate value add. So we can look at this idea that we know for a fact that GovCloud's Elastic Load Balancer doesn't have the full array of features of AWS's Elastic Load Balancer. And we can look for where things are lacking and see if we can design a technical solution that brings some of that stuff into this new model. And lastly, zero trust networks are not the right solution right now, but they are the future. And who knows what 10 years from now this is going to look like. We're not going to see a stop in how networks, perimeters are dissolving. Like, the more we integrate technology into our lives and the way we work, the more these issues are going to continue to expand and degrade the concept of a network perimeter. So at some point, we have to start getting the government to move over to something that they can eventually jump off and hit a zero trust network, because reasonably speaking, that's probably what things are going to look like going forward. So how can we use this as an opportunity to get them headed in the right direction, so that as that aspect of technology matures, they're able to evolve with it? So lastly, there's the question of, like, why exactly is this so hard? It amazed me when I was sitting and having a conversation with DHS, and I brought up the concept of packet mirroring, how easy that conversation was. And I had this moment where I was like, you're telling me 5 years and like hundreds of engineers, no one has ever suggested to you that perhaps we could just mirror the traffic over? Like, that's the way intrusion detection works in the first place. But these things are hard because there's a lot of, like, mental separation that has to go into the way you examine the problem itself. So when TIC policy was originally written in 2007, it merged the concepts of software as a service, cloud hosting, and mobile devices. It treated them as if they were all the same. They're not all the same. They've grown into, like, completely different things that require a completely different security attitude and perspective. So in order to fix the policy, people have to become aware of that fact. They have to separate these policies out and treat them differently. Also, getting people to separate their current needs from their future needs, from their wish lists takes a lot of, like, careful conversation. We had to have the same conversation with the same people over and over and over again, just to make sure that we were all on the same page and we're all defining things correctly. The people who are good at writing policy and the people who have technical expertise are rarely the same people. I've learned a lot of really interesting things about writing policy and, like, Oxford commas and, like, how you should never use and/or in a policy because it's kind of counterintuitive. It's either an and or it's an or. But I've also taught a lot of things about, like, how technology works, how networks work, what you can do with the cloud. It's really about making sure that these people are able to find each other, because sometimes they have trouble finding each other, and the policymakers can't write good policy if they don't have good technical advice. Lastly, if the best solution can't be understood by its users, it's not a solution. And I've just now realized there's a typo in my slide that's fairly hilarious. you know you work on something for a certain period of time, and it's you never catch anything. All right, so like if the best solution can't be understood by its users, it's not the right solution. So what's our current status here? The TIC working group's output contributed to a memo that was put out by the Office of American Innovation. Actually, I take that back. The memo is not officially put out. It has just closed public commentary. So you can go online and you can read the draft, but it's not officially out until they adjudicate all of the comments. By the way, they do this all on GitHub. It's fairly cool. Our output was contributed to the Office of American Innovation's IT modernization strategy, and that report basically said, hey, you know what, let's start experimenting with some of these ideas. Let's take a few projects at a few agencies and just kind of take the leash off and say, like, all right, if you wanted to do TIC for the modern age, show us what you would do, and let's collect data and figure out what the policy should look like going forward. The acting federal CIO has basically put TIC policy as one of the top priorities for the stuff she wants to fix going forward. So I actually have a little bit of extra time, which is cool. So I'm going to a little side commentary about why policy, not necessarily specifically tech policy, is so difficult to do. So this is generally how policy gets written. It gets drafted, then it gets sent out to agencies for comment, then it gets sent to the lawyers who pick nits like you wouldn't believe, and then it gets sent out to the public for public commentary. And this all looks very simple and very intuitive, except that at any point in time, if there's something highlighted that's serious, it kind of resets itself and you go back to the beginning. And then you get into this fun conversation of exactly how many agencies are there in the federal government. You have no idea how hard a question this is to answer. So officially, there are, I think, 24 CFO Act agencies. So you can think of those as the big ones: Department of Defense, Department of Treasury, so on and so forth. But if you start breaking down all the little ones, you could get anywhere from like 100 to 400. And then you have these fun conversations about, like, so does Freddie Mac and like Fannie Mae have an opinion on this? All these little like things that straddle the lines between private sector and government. And then when you get up to the public commentary section, you have to remember that when we say public commentary, we mean individuals like you are welcome to make comments on government policy, but more likely we mean corporations and lobbyists who do not write short comments, I might add. So for a little bit of fun, let me show you. This is Google's public comment on the, ooh, okay, that did not work. But I have a lovely desktop, don't I? Oh, no. OK, well, I can't show you. I was mirroring displays. No, it's all right. I was going to show you Google's comment. You can actually go to GSA's GitHub IT modernization into the comment section and download it for yourself. But it's like about 2 to 3 pages of Google advertising how great all of their products and services are, followed by 2 pages of comments on what the actual policy was. And when you read the corporation comments, they're all basically like that. It's like, so here's a background in which we tell you why you should give us all the money to fix all of the problems that you've highlighted. And oh, by the way, we have some comments on your actual policy. So I'm about at the end of my time. Thank you so much for listening. If you guys have any questions, we set up a Civic Tech channel on the Slack. You can ping me, Marianne, or you can just hunt me down. That's cool, too. Oh. Thanks.